Number one tells us to use the fundamental theorem of calculus to find the derivative of this interval. So you have two options. You could actually find the antiderivative and then do the derivative, or we could remember that in the fundamental theorem, as long as it goes from a number up to a variable expression, all that's going to happen is our t will get replaced with this. So my t squared will become x squared squared, so x to the fourth. And then what else do we have to do? We wouldn't. The antiderivative would have a plus c, but when you do the derivative of that constant, it would go away. Because this wasn't just x, we have to do chain rule, so times the derivative of that inside, which is 2x. Now, the other option is to actually do the antiderivative. And you would probably have to FOIL that out first to do your antiderivative and then do your derivative from there, but you will get to the same point. So if I'm saying fundamental theorem of calculus, all you have to do is replace the t with your variable expression and multiply by the derivative of that expression. All right, so this one, same thing, we're finding the derivative, but things are flipped. Remember, it has to go from a constant up to the variable. So if I need to flip it like this, what do I have to do? Okay, so my t gets replaced with my 4x. So I have a negative cosine of 4x cubed times the derivative of 4x, which is 4. Okay, you could write it like this. You could say 64x cubed if you actually wanted to cube that out, but either way, it's fine. So, fundamental theorem questions. We originally, when we learned this, we worked them all out and found that that's true, which you obviously could still do. But it's much shorter to realize the only thing that changes is your variable gets replaced. And then chain rule if necessary. And if you need to flip the limits, you throw a negative in front. Number 3, we want the area. So let's talk about where this hits the x-axis first. So take an x. That factors into x plus 3, x minus 5. So it hits at 0, negative 3, and 5. Okay. You could remember like x cubed. That's like a chair, so your behavior is down, up, or plug in if you test points to c. But that's what our function looks like. Now, if I am finding the area, we are just integrating. However, it says find the total area enclosed between that and the x-axis. Remember, if I just integrate from 0 to 5, it's going to say this is positive and this is negative and subtract them off. So if I want the absolute value of that, we're going to have to break it into pieces. If I go from negative 3 to 0, my function is above the axis. So we don't have to worry about it. But when I go from 0 to 5, it was below the axis. So how do I get that so the area would be positive? So it'd be a negative x cubed plus 2x squared plus 15x. All right, so if I do my antiderivative, sorry, I didn't leave myself enough space. I'm going to do this on 2 lines here. 0, we get 0. If I plug in a -3, and if you plug that all in, you should get 863 over 6. So total area means you have to figure out if it's above or below the axis. If it's below, you have to run a negative through there so that you're getting the absolute value of it. All right, then we just had a bunch of integral problems. Can you do the antiderivative of a product? No, because if I were doing the derivative of a product, I'd have to do product, right? What was our strategy on these types of problems? Substitution. We let u be the inside. And then we had to find du. Now, very careful. du. I am not getting that by looking at this original problem. I'm getting that by doing the derivative of u. So that would be 16x cubed dx. Okay, I need the x cubed and the dx. I don't need the 16. So to replace x cubed dx, I'll have to do 1 over 16 du. So my integral. We have a sine. The 4x to the 4th is my u. The x cubed dx is my 1 over 16 du. Is everyone with me there? This is something we can do the antiderivative of. What has a derivative of sine? And the 1 over 16 just stays since it's a coefficient. Since we don't have limits, we get a plus c. So it's a negative 1 over 16 cosine. Replace your u, that's 4x to the 4th plus c. And how can you check yourself on any of these questions? Do the derivative, yeah. Next one. We're going from 0 to pi over 2. Sine squared x, if you need to rewrite that, means sine of x squared. Again, I have a product because I have sine x times cosine x, so we have to do u. U is the inside. If you rewrite that sine squared as sine of x squared, we can see that sine x is the inside. Du, what is the derivative of sine? Derivative is just regular cosine. So this part will become my du. This part is my u. Now you have two options. And when we did these in class, we were kind of split. You can keep the 0 and pi over 2, but that means at the end you have to replace your u back with sine x. The other option is you can change the 0 and pi over 2. If you do that, you're plugging them in here for your x. Sine of 0 is 0, Sine of pi over 2 is 1. Okay, I typically change them, but I know a lot of you did not, and it doesn't matter as long as you work the rest of the problem out based off that. So if you change those limits, it's the integral from 0 to 1 of u squared du. Antiderivative of u squared is 1/3 u cubed. We don't need a plus c because we have numbers to plug in. Now this is the point where if you did not change these to 0 and 1, you would have to replace your u with a sine x and then plug in the 0 and pi over 2. If I replace them, we get our 1/3. Number 6. Okay, so again, we have a product. We have things with u, or things with x being multiplied together. So we cannot do the antiderivative of a product. So we start with a u. U is the inside, so inside would be under my radical, x cubed plus 1. Du. Derivative of x cubed is 3x squared. And we have a dx. I need the x squared and the dx, I don't need the 3. So that means I will use 1/3 du to replace my x squared dx. Are we doing okay with that? You made it back.
Yep.
All right. Thank you. Yep. So, if we choose to go ahead and change our limits, if you put a 0 in for the x, 0 cubed plus 1 is 1. If you put a 2 in, 8 plus 1 is 9. Okay, again, if you don't change those, you just have to replace your u back at the end. Then, the x squared dx is getting replaced with my 1/3 du. And inside, I had the square root, so that would be like u to the 1/2. So, antiderivative. If you add 1 to the power, 1/2 plus 1 is 3/2. Some of you are messing up on these coefficients. If you need to, write it out. We have a 1/3, we have to multiply by the reciprocal, the 2/3. So that gives me 2/9, u to the 3/2. If you change your limits, we're ready to plug in. If not, you have to replace your u. Okay, a 3/2. You guys should be able to do that without a calculator. That means the square root of 9 cubed, square root of 1 cubed. So square root of 9 is 3, 3 to the 3rd is 27, square root of 1 is 1, 1 cubed is 1. So 26 times 2/9 is 52 over 9. Is that okay? Number 7. Okay, I can't just do this antiderivative because I have x's being divided. It's a quotient. I can't do product or quotient rule in reverse. So that's what tells me I need to do a u. U is the inside. That may be a little bit harder to pick out here. But I like to think about if I'm going to plug in a number for x, where am I going to start? And if I were putting in x, I would start inside my parentheses. So that's going to be my u. Another trick is look, if you're just dealing with x's, look for the higher exponent. That's probably where you need to start. Then du. Derivative of x to the fourth is 4x cubed. 5 goes away, get a dx. I need a 2x cubed dx. So you have different options. What did you guys divide over? Did you go ahead and divide the 4 over, or did you just divide by a 2? And that's just because he realized we have a 4 to get a 2, all I need is divide by a half. If you didn't catch that, divide the 4, and then you'll just have the 2 times the 4. So you'll get to the same point. So, when I do my interval, if I wanted to change my limits, if I put in a 1 for my x, 1 to the 4th is 1, minus 5, negative 4. If I put in a 2, 16 minus 5 is 9. Again, if you don't want to change those, you don't have to, right? Oh, that's not 9, that's 11, isn't it? So if you don't change them, then at the end you just replace your u with x to the 4th minus 5. So we had u on the bottom, so that's like a negative 2 power. And the 2x cubed dx is getting replaced with the 1/2 du. Antiderivative of u the negative 1/2, or u the negative 2, if you add 1, you get negative 1, so we get a negative 1/2 in front. Okay, if you put in 11, 11 to the negative 1 means 1 over 11, minus negative, so plus 1/4. This would be 15 over 44 times negative 1/2, negative 15 over 80. That's everything on the first page. Are there any questions? So remember, you might need to look back your fundamental theorem of calculus and substitution rules. That's essentially what the first page covers. 8 and 9, we have a couple remaining derivative questions. These are ones where you could choose to do substitution, or you could choose to reduce first. When I look at this, to me, this isn't a substitution type question. I have x's being divided, but can't I simplify that? Since there's only one term on the bottom, x cubed over x will give me x squared. This is like 2x to the 1/2 divided by x, so that would be 2x to the negative 1/2. So don't forget, you can simplify first. And then this is an easy derivative. Antiderivative of x squared is 1/3 x cubed. Here, if we add 1 to the power, we get a 1/2. So that means we need a 2 in front times the negative 2 that's already there, so that would be a negative 4. And what else do we have to have? Yes. If we don't have limits to plug in, we need that plus c. Okay, number 9 could be done either way. We have v's being multiplied together, so we could do substitution, or it's only to the second power, you could multiply it all out. What did you guys do? Multiplied everything out? You guys okay if I do that method? Okay. So if you FOIL that, you get v to the 4th plus 4v squared plus 4. So if we distribute our v, we get v to the 5th plus 4v cubed plus 4v. So antiderivative of v to the 5th, v1/6, v to the 6th. Antiderivative of 4v cubed, bv to the 4th. Antiderivative of 4v would be 2v squared, and since we don't have limits to plug in, plus c on the end. The next question is really just interpretation. What does this mean? We've learned that a derivative is a rate of change, and we've talked about that for a long time. So the antiderivative is going backwards from the rate of change. So RT is the rate the oil is leaking in gallons per minute. So what would this interval represent? Yes. Total gallons of oil that leaked. What do the 0 and the 120 represent? So I could say in the first 120 minutes or between 0 and 120 minutes. So RT was the rate. When you go backwards, you're getting the amount. So if I gave you a function where you were integrating like the rate of sales, when you go backwards, you would get the amount of sales. All right. Then we had all the remaining questions were areas and volumes. So I did ask for sketches on these, not because I'm really wanting to grade your artwork, but because it's helpful in setting up your problem. We wanted the region enclosed by y equals 6 minus x squared and y equals x squared minus 4. We know x squared is what? A parabola. 6 minus x squared. If you have a negative x squared, that means our parabola is opening down. Okay, x squared minus 12, that started at negative 12 and is opening up, right? Now, is my picture anywhere near accurate? No. You could make it better. You could find exact points. On the test, I'm just really looking at, do you at least have an understanding of what's on top? And why do I need to know which one's on top? Yes. Okay, we do need to find our limits. So we need to figure out where these are equal. So if I add over my 12, add over my x squared, divide by 2, square root with that plus and minus, so x equals positive and negative 3. So we are integrating from negative 3 to 3. Area, this was the basic. Area is just top minus bottom. What do you do if you mess it up? Yeah, we know it has to be positive. So that was the top, this is the bottom. If you get to the end and you get a negative, that means you put the wrong one on top. So it doesn't mean you have to redo your entire problem. You just have to recognize it should be the absolute value. You could do your antiderivative first, or you could combine like terms. I'll combine like terms. So I would get 18 minus 2x squared. Antiderivative of 18 is 18x. Antiderivative of 2x squared would be 2/3 x cubed. If I put in 3, 18, put in negative 3. And we get 72 for the final answer. Don't forget to integrate these. You have to find out where they meet, so you set up your limits, but a couple of you have a bad habit of, once you set it up, just plugging things in. That integral symbol is there for a reason. You have to do the antiderivative before we plug in. Any questions on that? Okay. This one may be a little bit harder in terms of solving. We can do it either way, but since they're both already x equals, do you just want to work with the y's? So So to find our intersection, we had 3 points. They intersect when y is 0, 1, and -1. Now, you have to figure out these graphs somehow. So you can plug in points. You could realize this is just a line. Y equals x minus 1. So y-intercept is -1, slope of 1. Okay, and then if you're trying to plug in this one, maybe that's a little bit harder. Bless you. You could plug in some points if you needed to. If you put in a 0 for the y, we get x to be 1. Okay, so I'm kind of doing my t-chart in reverse. If y is 1, we get x to be 2. If y is -1, we get x to be 0, which we already knew those, right? Because we knew those were the intersection. If you're trying to get a better idea, and on the test, when you don't have a graphing calculator, you can plug in like maybe 1/2 and -1/2 for your y to get a better idea. If I put in a 1/2, I get 1/8 plus 1. So that's 9/8. So when my y is 1/2, I'm getting 9/8, which is a little bit more than 1. So it's my x here is just past 1. When I put in a -1/2, I have -1/8 plus 1, so that's giving me 7/8. So that's a little bit less than 1. So it looks kind of like this. Now, this picture's hard. What do you do if you mess it up? We do the absolute value at the end, right? So we are finding these areas. We have to break it apart. If you just go from -1 to 1, you're going to get a 0 at the end. So we're working in terms of y. So when y is -1 to when y is 0, plus when y is 0 to y is 1. When you are working in terms of x, we do top minus bottom. When you're working in terms of y, you do right minus left. So the right curve here was my y cubed plus 1 minus my left curve was my line y plus 1. For the next piece, the right curve is the line, y plus 1, minus my cube so if you're working in terms of y, right minus left. Is everybody okay with that setup? That is the hardest part. Personally, I would probably combine my terms before I integrated, so we get y cubed, my 1's cancel, minus y. This one will be y minus y cubed. So if I do my antiderivatives, the antiderivative of y cubed will be 1/4 y over 4, minus the antiderivative of y will be 1/2 y squared. Multiply this with 1/2 y squared. That's 1/4 y. So plug in, we get 0, minus if I put in -1. The opposite of -1/4, so 1/4 plus 1/4 is 1/2. what questions do you guys have for that one?
When you determine like which one to put where,
Mm-hmm.
if I did it in terms of X,
You would do top minus bottom. If you did it in terms of X.
so you did, because it was Y, it was because the Y was.
Yeah, because I used Y for my variable. These were Y values. So I did right minus left because you want to have it positive when you move.
Okay.
If you were trying to set this one up with X's, you'd have to go like from when X is 0 to when X is 1. The top curve was your line minus the bottom curve. So this one you would have to solve would be like the cube root x minus 1 dx. And then do the other way. Any other questions there? Let's see if we can get through the rest. So 13, we want the area bounded by the graphs. Y equals 3x plus 1, y equals 7, and the y-axis. So here's my y-axis. 3x plus 1 is a line, y-intercept of 1, slope of 3. And y equals 7 is just a horizontal line of 7. So I'm just finding this area. This one I think we can easily do in terms of x. So you do have to find the intersection point. So if you set the curves equal, that's when x is 2. And so we were starting right here. What's the x value right there? 0. That's from the y-axis. So 0 to 2. The top curve is 7 minus the bottom curve is the 3x plus 1. So that's 6 minus 3x. Antiderivative of 6 is 6x minus 3 halves x squared. So we should get 6 for our answer. Problem 14. And I know if you hadn't tried all these problems, I'm probably not giving you enough time to write everything down. So you probably need to make sure you are going back, working them, rewatching the video, and studying tonight if you hadn't done them before you got here today. We are now finding volumes. So we have the solid obtained by rotating the region bounded by the curves. X equals 3 radical y. So you can do different things to figure out what that looks like. If you wanted, you could plug in some values for y. We can't put in negatives, can we? So you could do like 0, 1, and 4. If you put in 0, you get 0, 3, and 6. So you get 0, 0. At the beginning, if you'd also just solve for y, you would see you're dealing with a parabola. Again, I'm not checking the accuracy of your artwork. Just do we have a rough sketch? X equals 0 just means I'm starting it here. Y equals 9 is giving me a stopping point. So I'm taking this, rotating that around the y-axis. So if I start rotating this around the y-axis, then we get this goal. We have a clear top and bottom point, right? So we're going to go from 0 to 9. If we look at a cross section, what shape is our cross section? Circle. So we just did the area of a cross section. So that's pi times the radius squared. Okay. And then we have to decide what we're working in terms of. Now here's where it's a little bit tricky. If we were rotating around the y-axis, which variable did we typically work in terms of? So when we did shells, we did it that way, it flipped, but when we just did our basic x-axis, we did it in terms of x. Y-axis, we did it in terms of y. So that means I should probably work in terms of y. It'll be a little bit easier. Now, I think my limits are still okay because when y was 0, x is 0. When y is 9, x is 9. So these are still y values. So if I'm working in terms of y, this is just my radius is the 3 radical y dy. And the reason it's easier to work in terms of y is right here. You're looking at this radius. It's just from here out, and we already said this curve is 3 square root of 4. Okay? So we could take out the pi. 3 squared is 9, radical y squared is just y. Antiderivative of y would be y squared, so we need a 2 in front. -0, so 729 pi over 2. Any questions on that? So if we're rotating around the y-axis, probably easier to work in terms of y. Number 14, or sorry, 15. This one we're rotating around the x-axis, so we'll work it in terms of x. Okay, y equals 8 minus 2x. That's just a line segment. But I already told you you're only going from 1 to 3. So we're just taking that part, we're rotating it around the x-axis. I'm running short on time, which is why I'm not doing a very great picture here. Okay, so when I set this up, your limits are already given. We're just going from 1 to 3. A cross section is still just a circle. So it's just pi times the radius squared. And we said we're working in terms of x. Your radius is just from here to here. And we already know that formula is 8 minus 2x. So if it were me, I would probably FOIL. Antiderivative of 64, so 64x and 16x squared is 4/3 x cubed. Should give you 104 pi over 3. So we're just rotating the line around the x-axis. Lucky for us, I gave us a clear starting and stopping point, so we just had to integrate from there. All right. Number 16, I want the solid obtained by rotating the region bounded by the curves, y equals x squared. So y equals x squared is a parabola. Y equals the square root of x and the x-axis. So we need to know where these meet because I want the region bounded by them. our intersections at 0 and 1. So we're just looking between those. Okay, so x squared, that's a portion of a parabola. Square root of x is like flipped on its side. So we're taking that, rotating it around the x-axis. So x-axis, better to work in terms of x. When you look at a cross-section this time, what's it look like? Yeah. We've got this cone shape being formed, so our cross-section is more like washer or donut shaped. So when we set these up, we already found we're going from 0 to 1, and we already said we're working in terms of x. So pi, since we have two circles, we do outside radius squared minus inside radius squared. So the outside one was my square root graph, that was the one on top. Inside one was my parabola. So that's x minus x to the 4th. We have 3 pi over 10. Again, just like areas, those volumes should be positive. So if you're getting a negative, you've made a mistake somewhere. Okay. And the last question, I asked you to use shells for this one. So remember the shells, it's not that it's always the only way, it's just another tool. So if I want you to use shells on the test, I will specifically say use shells to do this. And it's more like finding like our 3-dimensional shapes and stacking them up. We are talking about y equals 2x, y equals x squared, and rotating around the y-axis. So 2x is just a line. And if you want, you could go ahead and find their intersection points. So we can see they're intersecting at 0 and 2. So we have that line and the parabola. Okay, shells wouldn't be necessary here, but if I ask you to do it that way, that's how we're going to set it up. So we are rotating that around the y-axis. Coming this way. This is the one where we kind of did it opposite. Even when we're rotating around the y-axis, we typically set up our shells in terms of x. So we already found our x's to be 0 and 2. Right, so our shells would like be taking chunks out of here and finding the volumes of those chunks, essentially. When we look at that, we said you have to do 2 pi times the radius, which if we do it this way, that's why we do it in terms of x, so our radius is just x, times the height of that. So the height of the shell right here is the line minus the parabola, because the line's on top. So 2x minus x squared. Okay, so we